Now, I want to take you to a next step in this little story. It turned out the protein we were using to increase cancer, and what the Indian workers have done too, by the way. The protein we were using was the only one that was generally available to researchers. It was casein. That's the main protein of cow's milk. I came from a dairy farm. Now, I think you can understand. I said, what in the world? Dairy protein, the main protein of cow's milk, turning on this cancer? Give me a break. This is crazy. So we tried a little bit later on a couple of plant proteins to see if they did that, and they didn't. We did it in many different ways. The plant protein, soy and wheat in this particular case, they don't increase cancer development, even when they're fed at these high levels. So here's something selective just for the animal protein. Now, let's stop there for a moment. I call those studies biological plausibility. It tends to show that the high protein diet actually increases cancer, and we know a lot about the mechanisms that cause this to happen. Now, I want to just jump into a different planet here for the moment. And I just actually gathered these data here not very long ago. Wait a minute, I lost my slides. The slides jumped off the thing. Sorry about that. Okay, here we go. Sorry about that. But in any case, just recently, maybe 5, 6 years ago, I wanted to go back and see what is the relationship between animal protein consumption and various disease rates. Okay, this is work all done by others in past years. Let me show you some slides here that are just remarkable when you compare them all together. Here's a relationship between, let's say, I've got to go back one. I had one right here. This is a relationship between increasing protein intake. This is a screenshot, actually. The researchers showed that it was with increasing percent protein, they get increasing rate of heart disease for all these different countries. Look at that line. I drew the regression line myself and used a certain algorithm. The line is a straight regression line all the way down, almost coming right down here at 0, 0. In other words, zero animal protein, no heart disease. Then here's one here. This one is a kidney cancer. Another researcher did this. Okay, the higher the consumption of kidney cancer, the higher the protein intake, the more kidney cancer. Again, a totally different research group. They don't even know each other. They're just publishing this, right? I drew a line through there, and that's what you get. Almost the same thing, the line coming all the way down to this XY origin, if you will. Okay, here's one for prostate cancer. In this case, they didn't say animal protein. What they said was non-fat milk, okay? Associated with, of all things, prostate cancer. Look at that. That's inarguable. Nobody will ever show the opposite. As we increase for these different countries, as non-fat milk consumption is increased, as skim milk, the higher the rate of prostate cancer. And we know quite a lot about that. But they called it non-fat milk. Now, non-fat milk, by the way, is basically nothing more than a protein drink. In other words, the milk has no fat in it. That's what, by definition, about all is left is protein. So this is animal protein, increasing that. Here's another one, still another researcher. I happen to have known this in some years before he passed away, a friend of mine from Canada. But in any case, he was able to show that as he found increased saturated fat intake, then the higher the rate of breast cancer, death, breast cancer mortality. Again, a straight line. He called it saturated fat. But guess what? Saturated fat is a representation of, I don't know what's happened to my thing. That's a representation of animal protein. Now here's yet another one. Here's cholesterol intake versus coronary heart disease, CHD. We got the axes flipped here in this particular case. The higher the cholesterol intake, the higher the heart disease rates. Again, see that line? Come right now. I hope you see here there's similarity between all these sort of regression lines. Here's one for meat consumption, colon cancer. Each of these are separate researchers. They kind of published 60 years ago. I went back in the literature, was kind of bringing them up and recalling them in sense and finding the regression lines for these. Now we got meat consumption. Here's one for uterine cancer. This is total fat consumption for different countries and uterine cancer. What do we see in all these lines? All these lines are doing the same thing. They're regression lines. They come right back near the zero, which tends to say, as soon as we start eating some of these things that are all animal protein, we start to see disease risk. And we see a number of different cancers and heart disease here, if you will. So my conclusion from these studies is to say that cholesterol, when we consume more cholesterol and meat and total fat and low fat milk and saturated fat and animal protein itself, of course, these are all surrogates. My thing, I'm sorry, getting ahead of myself here. These are all surrogates for animal protein consumption. The researchers did not know that. The researchers focused on, skim milk is not good. Meat's not good. Total fat's not good. Low fat milk's not good. Saturated fat's bad. Look at all these here sort of representations that really took a life of their own. We've heard about them, a lot about them now. They're not really just these kind of things. They all have one thing in common. They're all a representation of animal protein intake. Now, to go back, what about plant protein? One of those I showed you before, my friend from Canada back in the 1980s, he looked at the relationship between plant protein and intake of breast cancer, no relationship. So all those lines, those regression lines are just for animal protein consumption. So there you have it. What I showed you in the first few slides was the mechanism, a bunch of mechanisms all working together, unmistakably increasing in an experimental setting, unmistakably. Each one of these mechanisms being different locations in the cell and so forth and so on, working together to produce increased risk of cancer, but increased risk of other diseases too when you compare it. So I don't know, there's a lot more research. I could never give another 20, 30 lectures just on this subject, because this was the area I worked at, it was animal protein. The animal protein turns out not to be what we think it is. It's not what we think it is. And so I have been, running at some risk of my career for some years, talking about this animal protein effect. Of course, I'm going to go beyond that a bit. So today we're left with still this impression on the part of the public. Most people in the public, I would say, certainly the corporate sector and the medical sector, but everybody tends to think that protein is good. We need it. Yes, we do. Yes, we do. But we don't need it from animals. Animal protein does this dirty work, quite frankly. Plants don't. Plant protein doesn't. So I think we have a serious indictment against the consumption of animal protein. That being said, now I'm going to turn your attention to something else that's happened. Namely, this is a representation of some information that was developed by the so-called Institute of Medicine, the National Academy of Sciences, a very distinguished group, who set the recommendation for nutrient intake of all different kinds. In this case, I'm just showing you the representation of protein intake. These are different levels of calorie. I'll show you in a moment what this means. Okay, so I got a line here. This is the scale or the spectrum of protein intake from 5 to 6% of calories up to 22% of calories. Okay, let's see what we learned about this. This was what was published in 2002. It has long been established since 1943, to be exact, that the minimum intake of protein we need for good health, and protein is necessary, we need protein, but the minimum intake that we need for good health is about 5 to 6% of calories. But that's the minimum requirement, if you will. And so in those days, the researchers decided, hey, this is not, let's set this up by a couple of standard deviations, just to make sure everyone gets enough of this important protein. So they set up around 9-10% or so. That came up to the number we call recommended daily allowance of protein. It's around 10% of calories. A lot of people have heard that in terms of grams per kilogram of whatever body weight, but it's around 9 to 10% of total calories. Minimum intake, recommended daily allowance, okay? It turns out, and this started way back in 1943 and kept being updated through the years. But in any case, today, the intake of protein is right here, as you can see. The intake is about ranges from around 11% up to about 24, 25%. Some of us, are nearly carnivorous, and we're up here at the high end. This is the range of about 95% of our population, somewhere in here. This is the intake range of total protein, okay? It turns out of the total protein, 75 to 80% of our total protein average in our country, 75 to 80% of it is animal-based. So much of all this extra, We're consuming way more protein than we really should be recommended, more than we need. We're up here. The average, as I say, is just up here around 17% or so these days. Now, look up in the left-hand corner. I just see this a little scheme here, just showing you all those things I showed you a moment ago, that all these different diseases, if you look at the relationship between animal protein intake and these different diseases, they're all more or less the same. And all the diseases are affected like each other. I'm taking those plots here and I'm just pulling it on top of this. So what does this say? Here's our average intake of protein right here. And this is the range during which we see increasing rates of these diseases: heart disease, cancer, diabetes, and so forth. Okay, this is superimposed on top of that. So we're eating all this protein we don't need. Okay, and this is animal protein, and we are getting these diseases, not just because of animal protein. It's because of our desire to consume animal protein. And a whole bunch of things going on. But that's really what happens. As we increase the diet, having more and more animal protein in it, animal foods, the higher is the risk for these diseases. Unmistakable. This is unmistakable. This is a huge volume of data showing this over many years. So one more comment on this here, I should say, is that whole food plant-based diets, whole plant diets, they provide enough protein. You know, if we just eating plants alone, the whole food plant-based diets, at a minimum, they got around 8-9% or so. Actually, a lot of them are up around 15, 16, 17%. So that's fine, no problem. That kind of protein is not a factor. Not only is a protein not itself a factor, but also when we're eating plants, as many of you may know, we're consuming a lot of antioxidants, crude fiber, and so forth. So it's a combination of a whole lot of stuff going on here, affecting a whole range of different diseases, all driven by this sort of almost supernatural, intensity that we have for consuming animal protein. It's supposed to be something special about animal protein. And that's really what it is. We got so encased in that kind of thinking for centuries, decades, only over a century, that we end up eating the wrong diet. So with all that said, in 2002, this very distinguished body, the National Academy of Science, I know it very well, I was on panels myself there, the one that set these numbers, if you will, they came up with something new for 2002. They said the upper safe level, they were advised that they should set upper safe limits of different nutrients. Okay, they did that for all the different nutrients. As I say, this is one of the most recent versions, 2002. Now it's 20 years ago, but in any case, they had the upper safe limit for protein, 35%. 35%. I'm showing you here that any kind of animal protein consumed up here, we got serious problems occur. Why in the world did they say 35%? Okay, let me say a little bit more about that. I call it the mob power. These are distinguished scientists, supposedly at the Institute of Medicine at the National Academy of Science. It's chaired by someone I know really well. He's a very major consultant for the dairy industry in the world, probably the major consultant, at least for a few years he was. He chaired the committee that came up with this number here, 35%. Made a big report out of it, 1,400 pages I recall, something like that. I've got the paper out. I called some of my friends on the panel and said, what in the world did you do that for? And they said they didn't do it. And so I learned that this 35% figure was not really established by the committee itself. It was established by the news release that was controlled by the person who was in charge of all this. It was established by the news release as an upper safe limit, and it was told in major newspapers all over the place. Don't worry, folks. We can consume protein up to 35% of calories, or eat all you want. That is basically a ticket. Eat as much protein as you can, and that usually means to most people animal protein. So with this data, I just showed you prior to this, and I could show you tons more than that. Here they are coming along in the year 2000, 2002, saying we're not getting enough. We're not getting enough. Well, it just so happens that I'll come back to that a little bit later. That is driven by people there who have a conflict with the industry who stands to gain from consuming more protein, and that's the animal foods industry.